It's good to have a general idea of the product and the quotient rule without there actually being any functions to derive. And that's what example 9 is all about. We have two functions f and g, and we're going to say that they're differentiable. We can take the derivative wherever we want to, but we don't know what f of x and g of x have for their exact formulas. What we do know is that f of 1 is 3, and g of 1 is 4. F prime of 1 is negative 2, and g prime of 1 is 5. Okay, so we have just those four specific values, and we're going to use those four for the two parts. Okay, so part A says let's come up with another function h, and that function h is just f times g. What is h prime of 1? Okay, what value is that? We can actually figure that out based off of this right here. But first we have to do the derivative, which means we have to understand that f times g is a product, and therefore in order to get the derivative of h, we have to use the product rule. So let's get h prime for starters, h prime of x. All right, just separate ourselves there. Well, again, it's f times g, which means that we need the derivative of the first times the second plus the derivative of the second times the first. We have to use the product rule in order to get that done. Now, we're interested in h prime of 1. So we're going to replace x's with 1s. So we have f prime of 1, g of 1, plus g prime of 1, f of 1. And if we replace all of those with what we know up here, we're going to get our answer. F prime of 1 is negative 2. G of 1 is 4. G prime of 1 is 5. F of 1 is 3. So we have negative 2 times 4, which we know is negative 8, plus 5 times 3, which is 15. And negative 8 plus 15 gives us our final answer of 7. So h prime of 1 is 7. We're able to get that based off of the given information and the fact that h is the product of f and g. We can do the quotient rule as well. With regards to the quotient rule, a of x is g divided by f. Kind of switched it from before. Okay, so let's get a prime. A prime, the derivative of a, using our quotient rule, bottom d top minus top d bottom all over bottom squared. Bottom times the derivative of the top. So f of x times the derivative of the numerator, d top, g prime of x. Minus, remember the numerator has a minus sign for the quotient rule. Now we flip them. Now it's top d bottom, top d bottom. So g and then f prime. G of x and then f prime of x. All over bottom squared. I want to write g, but I don't actually want, I want f of x there. So all over f of x squared. Should put brackets around that. Okay, so let's plug in 1. F of 1 is 3. G prime of 1 is 5. So we have 3 times 5 minus. Now we want g of 1, which is 4. And then f prime of 1, which is negative 2. All over f of 1 squared. F of 1 is 3, so 3 squared. All right, 15 minus negative 8 all over 9. 15 minus negative 8, that's 15 plus 8, that's 23. So we have a final answer of 23 over 9. So again, we can get product and quotient rules done even if we only have general functions. We don't actually have specific formulas. The product rule and the quotient rule still apply. And they love to do that in the exam where they want to see if the students can identify, hey, this is a product, so let me do the product rule even if I don't know what exactly f of x is equal to. Or even if I don't know exactly what g of x is equal to, I can still do a quotient rule because I'm not interested in f or g, I'm really interested in the derivative of a or h, which require the product rule or the quotient rule.